Hello, and welcome to my video. Today, I'm going to be talking about the Doppler effect. Now, the Doppler effect is a change in the frequency of a sound when the sound source and the receiver are moving either towards or away from each other. If the sound and the receiver are moving towards each other, the frequency increases. But if the sound and the receiver are moving away, the frequency will decrease. And if they're standing still, or they're moving in the same speed, if they're standing still or moving in the same direction at the same speed, there will be no effect. Now the question you want to know is, what is the frequency you're perceiving? Because it won't be the same as the frequency being coming from the sound source. Let's say you're sitting on a train station and a train is coming and you hear its horn blaring. The train horn produces a frequency of around 2000 hertz, but that's not going to be what you're hearing when it comes past you, or goes past you, or even comes towards you. So in order to figure out the frequency that you're receiving, you need to use this equation right here. F equals Fs times C plus CR divided by C minus CS. Don't worry, I have a list right here of what those letters mean, and I'm going to go over it with you. F is the apparent frequency. That's the frequency you're trying to receive. That's the frequency you're receiving that you're trying to figure out. Fs is the frequency of the source. So let's say you hear a train coming and it's blaring its horn. The horn from the train is blaring a frequency of around 1000 hertz. Let's say that for an example. That's what you're going to put for Fs. C stands for the speed of sound in air, and the speed of sound is 1130 feet per second, plus CR, which is the speed of the receiver. So let's say you, as the receiver, are booking it at 15 miles an hour towards the train. You have to implement that speed right there. But you can't use miles per hour. You need to use feet per second. And in order to convert miles per hour into feet per second, you need to use the miles per hour times 1.4, like 6 sixes, like 666, 666, equals the feet per second. The same would go for the speed of the speed of the source, which is CS. So altogether, it would be hertz times speed of sound plus speed of the receiver divided by the speed of sound minus the speed of the source. And actually, I have a little example here to show you. Now that you've seen the video, you know what the Doppler effect sounds like too. But now we're going to use that to answer this question. Here I've written it down. A car is moving towards the camera at 30 miles per hour. The camera is stationary, which means it's not moving. The car horn has a frequency of 500 hertz. And what is the frequency perceived? Here, we need to convert the miles per hour the car was going to feet per second. So we're going to take 30 miles per hour and times it by 1.4666667. This will equal 44 feet per second, or around 44.25 feet per second, but we're going to say 44 feet per second just to save time. So the whole equation will be F equals 500, which is the hertz caused by the horn, times 1130 plus 0 because the camera was not moving, divided by 1130 minus 44, which is the feet per second. This will come up to 520.25 hertz. So if the horn is blaring at 500 hertz and we perceive it as 520.25 hertz, that means that the frequency has gone up 20 hertz. With that said, I hope this helps anyone who doesn't understand the Doppler effect or how to answer this equation. And I hope you have a good day.